Okay, this is a reteach for the first part of your quadratic function test, TEK A7A, which is key attributes, and we're going to do vocabulary quick first here as well. The vocabulary section count it as a quiz grade, so that's the 30% grade, and you can't redo that one, but most of you don't need to anyway. Okay, the U-shaped graph of a quadratic function is a parabola. Okay. Number 2, it's the discriminant. The discriminant can be used to determine the number of real number solutions of a quadratic equation. That's what's underneath the radical sign, the b squared minus 4ac, and you need that for the last part of the test. The line that divides a parabola in half is the axis of symmetry. The vertex of a parabola is where the parabola intersects the axis of symmetry. That's your maximum or your minimum point. The function f of x equals x squared is called the quadratic parent function. Okay, so those are worth 20 points each because there's 5 of them. Okay, this key attributes TEK. All right, so you have an equation here. You have 2 options. You can just graph it and make the calculator do all the work for you, analyze your graph, or do the graph trace. Or you can use the axis of symmetry formula, which is on your reference chart, opposite b over 2a. That will give you the axis of symmetry, x equals. So that's going to give you the x coordinate of your vertex. If I have an x, I can figure out my y, because I can just put this value in for these x's, figure out the y. So that gets me my axis of symmetry, my vertex, whether it's a maximum or minimum comes from the fact that this is positive, the coefficient of x squared is positive, greater than 1. So that means it opens up, which means I have a minimum because the graph is going to look like this. Okay, and then you get your maximum or minimum value, that's the y value. Your y-intercept is not necessarily your vertex. That's only true if the axis of symmetry happens to be the y-axis. So the y-intercept is the same thing as it always is. It's where x equals 0. So you can put a 0 in for these x's, and you will get -5. Okay, and then the y-intercept, oh, sorry, not the y-intercept. Hang on, where's my eraser? The maximum or minimum value gets you your range, and the domain, since these are not pieces of quadratic functions applied to a real life situation, they are just functions, the domain is going to be all real numbers. Okay, now here's the thing, if you use this x equals -b over 2a, you end up getting -1/6. Then you have to put your fraction back into that quadratic equation, which shouldn't be a real big issue since you have a calculator to help you with the calculations, but I'm guessing you would rather graph it and have the calculator do the work for you. So let me go input the picture that I graphed on Nspire, and we'll see how you do that. Okay, so here's the picture of the graph. Okay, so here's our graph. I'm going to make it bigger, and then I'll, just shrink it down, just so you can see. So the first thing I did was had the calculator calculate zeros. And you can see that's -1.47 and 1.14. A lot of y'all didn't tell me both points on the key attributes. There are 2 zeros for this function because it crosses the x-axis twice. Now, don't round these, just write them down like they are. So, let me move that. -1.47. And you could write the ordered pair, comma 0, and, what was it, 1.14, right? Yep. 1.14, comma 0. Or you could have just written the 2 numbers down. Okay, so if I go back to my calculator graph, I had it calculate the minimum. That's this point right here. Now, I know that's really close to the y-intercept. And I know if you round negative 5.08, you get negative 5. But you don't want to round here because there's a little bit of difference between the y-intercept and the vertex. Okay, the axis of symmetry is not the y-axis, and that's kind of important that you're accurate. Not everything is rounded to the nearest integer answer. That's why decimals exist in the first place, yes? Okay, so the vertex is negative 0.167, which is negative 1/6, and negative 5.08, which makes our axis of symmetry x equals negative 0.167, and it makes our minimum value negative 5.08, and that makes our range y is greater than or equal to negative 5.08. Okay, so the last thing then is looking at the graph to find the y-intercept, but it takes a little manipulation to get that y-axis graph, so I would suggest you just put a 0 in for x, or if you do graph trace, so you do, I'm trying to think, it says graph trace, and then trace all, or whatever that is, and then you can go along your curve. The little yellow boxes will pop up when you hit the y-intercept, or the zeros, or the minimum. Okay, so just look for those yellow boxes and you'll be okay, or you can always do Control T and look through your table. So you have a lot of different ways to find the y-intercept. Okay, so number 7. It's already graphed for you, so this one came out better because you just basically read off the graph. If you didn't want to do that, you could always put that into your calculator, analyze the graph, and all those things will pop up for you, or trace the graph and look for the little yellow boxes to pop up. So we see that we have a minimum value, so it's minimum, and that's right there. That's your vertex, so that's at negative 2, negative 1. The minimum value is the y value, so y equals negative 1, or if you just wrote a negative 1, that's fine. The axis of symmetry is the line here that goes right through the vertex, so that's x equals negative 2. The y-intercept I can see is right here, right there, so that's at 3, so 0, 3. Zeros, I can see my zeros right here. And right here, again, some people only wrote one of them down. Okay, so that's at negative 3 and negative 1. So you can write them in that sort of brace, or if you're writing down the points, the ordered pairs, you would do this. And negative 1 comma 0. Okay, domain is all real numbers. And when the calculator graphs these things, these functions, they don't put arrows on the end. So since this isn't tied to a real life situation and there are clearly not points there that tells you it ends, you're assuming these arrows are here. So we have all real numbers, and the range again is everything greater than or equal to negative 1.